Welcome to the fifth and final lesson of our Unit 3 on factoring, in our grade 10 academic math class. So this is a factoring summary we're going to tackle today, which goes over sort of all of the things that we've learned in this unit. So let's start with just a quick review. Factoring is the opposite of expanding and simplifying. So expanding is when you have a monomial and a binomial or some combination of terms, a collection of terms that you multiply out to end up with more terms than you started with. Factoring is the opposite of that. So you have a number of terms, whether it's 2 or 3 or 4 or more, and then you factor something out, which is like dividing it out. So the opposite of expanding, in that expanding is multiplying and then simplifying, factoring is like dividing something out without really losing the thing you divide out. You kind of just relegate it to a different configuration of terms where you have fewer terms than what you started with. We looked at I guess 4 different types of factoring. The first is common factoring, so looking for a common factor in all of the terms that you have to factor. We looked at simple trinomials, which is factoring a 3-term quadratic with a coefficient in front of the quadratic term of 1, and we have a procedure for that. We learned how to factor tricky trinomials, and the method that we learned to use is decomposition. And that is where you have a 3-term quadratic that has a coefficient out in front of the squared term that is not 1, it's something different. And then in our last lesson we learned how to factor differences of squares, where you have a 2-term quadratic that has 2 perfect squares separated by a difference, and we learned procedurally how to factor that. So this lesson is really meant to help you decide, given just any old collection of terms, how do you know which form of factoring to do? So we've created a flowchart. Let's start filling it in. So the first thing you want to do when given any collection of terms is to consider whether or not you can common factor. And that's looking for terms or components that are common to all of the terms in your expression. Once you've completed common factoring, if you can common factor, you need to look at the number of terms that you have in your expression. So we have either 2 terms, or we have 3 terms. Let's do the 2 terms first. If you have 2 terms, it's possible that it's a difference of squares, but it has to meet the criteria. So the criteria here would be 2 terms, which I guess it just says above. It has to be a difference. Oops, that's not a letter. Difference, meaning that the 2 terms are separated by subtraction. And lastly, you need to have perfect squares. And when we're talking about perfect squares, we're talking about terms that have 2 identical components that multiply together to give you the product. So that's the set of conditions that will say, yes, this is a difference of squares. Now we can go about factoring it following the difference of squares procedure. What if we have 3 terms, however? So here's a 3-term expression. And here we have, again, 2 possibilities. The first is that our a value is equal to 1. That would make it a simple trinomial. And the procedure for figuring out how to factor a simple trinomial is to find 2 integers that multiply to c and that add to b. And the c, of course, is the constant term at the end with no variable in it. And the b is the value on the linear term, the term with only one x. What if our 3-term expression does not have an a value equal to 1? Then we factor it like a tricky trinomial. Now again, in this particular version of the course, I did not teach you how to do systematic trial. I taught you how to do decomposition. So decomposition, where I'm not going to write out the procedure here since it's a little bit involved and kind of sort of hard to describe, I guess, a little bit. But essentially here, to do it verbally, what you're trying to find is the thing that multiplies to the a c value, but that adds to b. So we're now contending with not just 2 things that multiply to c, but the product of a and c, and that still adds to that middle value of b. And then you factor by grouping, and off you go. At the end, and this is an important step, and we saw this in probably some of the more challenging examples that we went over in our lessons, if at any point you have you arrive at the end of your factoring, it's important to look at your results and see if you can factor any of those factors again. Sometimes in factoring a difference of squares, you end up with another difference of squares. Sometimes after common factoring, you find out that you have a simple trinomial or a tricky trinomial left. So at the end, make sure that you're looking critically at your answer. Don't just think that necessarily one type of factoring is going to be all that you need in any given question. And if there is more to do, you go back up to the start, look for common factoring, and count up the number of terms you have. So that is just sort of a quick little walkthrough on an approach to factoring in general. What follows is a factoring, what is called here an assignment. It's really just some sort of mixed practice where it doesn't explicitly say factor simple trinomials, factor by common factoring, factor tricky trinomials. It's more general than that. It's just a collection of different things that you can factor. So I've selected 4 of them here just to sort of walk you through how they might be done. Let's start with A. So if we're going to follow that list from up above, the first thing we're going to look for is, are there any common factors that we can factor out? And there are not. The next thing we're going to do is count the number of terms. Here we have 3 terms, and the A value out front of our 3-term quadratic is a 1, which means we're going to factor this thing like a simple trinomial, where we want to find the thing that multiplies to our C value, negative 40, but that adds to our B value, which is negative 3. So again, have a look through your factor sheet and figure out what the combination of numbers will be. The correct combination will be negative 8 and plus 5. And those two numbers become the numbers that we have in our brackets. The brackets start with x's, since we have an x squared right here. 1 takes the negative 8, 1 takes the plus 5. Order's not important. You could put the plus 5 in the first bracket and the negative 8 in the second bracket. That works just as well. Okay, let's try a second example. Okie doke. Are there any common factors that can be factored out of this thing? Yes, there are. We're going to set this up to common factor something. So let's factor out the greatest common factor. And because there are 2 terms, we'll be left with 2 terms here. So the greatest common factor, at least in terms of the coefficient, is going to be 5. And let's look to the x's now. The greatest number of x's factorable out of both terms is x squared. And the greatest number of y's factorable out of each term is y squared. So now we have to fill in the brackets. When we factor 5 out of 10, we're left with 2. When we factor x squared out of x cubed, we're left with an x. And when we factor y squared out of y squared, we're left with a 1. So I'm not going to write that down. That would be like 2 times x times 1, so I'm just not going to write it down. When we factor 5 out of negative 15, we have negative 3. When we factor x squared out of x squared, we have a 1 again. And when we factor y squared out of y squared, we're left with a 1 again. So that would be like 3 times 1 times 1. I'm just not going to bother to write that in. And now that I'm at the end, I'm going to look and see, is there any other type of factoring that I can do? Well, I do have 2 terms in my bracket, but it's not a difference of squares. There's no more common factoring I can do, so this has been fully factored. What's the next one we want to tackle here? It looks like E. So, is there any common factoring that we can do? No, there is not. How many terms do we have? We have 2. Is it a difference of squares? Yes, it is. We have 2 terms separated by a difference, subtraction, and both the first and second terms are perfect squares. So we're going to find the square root of the first term, which is m, and we're going to find the square root of the last term, which is 64. That's 8. And now we're going to populate our brackets. Each bracket is going to start with an m, since that's the square root of the first term. Each bracket is going to include an 8 at the end, since that's the square root of the second term. 1 gets a plus, and 1 gets a minus. Again, the order here isn't important. It could be m minus 8 times m plus 8. That's also totally right and totally fine. All right, last but not least, we're going to tackle h. So here's h. We have 3p squared plus 16p plus 5. Is there any common factoring that we can do? There is not. Do we have 3 terms? We do. The coefficient out front, however, is not 1, so we're going to treat this like a tricky trinomial. So we want to find the thing that multiplies to plus 15. Remember, that's actually a times c, which is 3 times 5, which gives us our 15. And we want to find the thing that adds to positive 16. So again, the 2 numbers that are going to work for us here are going to be plus 15 and plus 1. So the first step in this one is to decompose that middle term down to plus 15p and plus 1p. Then we put the first term down, the second or the last term down, and now we have our decomposition completed. Now we have to do the factoring piece. So we're looking for the greatest common factor in just the first two terms here. The greatest common factor is going to be 3p, and when I factor that out, I'm left with p plus 5. And now I'm going to common factor the second two terms. So the greatest common factor here is just 1, so I write down plus 1. When I factor that out, I end up with p plus 5. Now I have two terms, first term, second term. The greatest common factor happens to be the binomial, the p plus 5. So I factor that out. And when I factor p plus 5 out of the first term, I'm left with just a 3p. And when I factor p plus 5 out of the second term, I'm left with a plus 1. And now I look at these brackets and ask myself, is there any further factoring I can do? And I can't. And that's the end of it. So the solutions to this assignment are on the class website. Give yourself some time to go through it, maybe review the lessons first before endeavoring this. It's certainly a good measure of how well you understand not only the types of factoring that we've looked at, but when and how to do them. So good luck with this. This is the last lesson in our unit number 3 on factoring. Good luck.